Bonjour tout le monde. Comment ça va? Well, don't worry, you are at the right place, and you are not tuned into a wrong webinar. Hello and welcome to a brand new webinar. I'm Atul, your host for today, and also a senior developer advocate at InfraCloud and a CNCF ambassador. The whole idea of me being in this role and doing this webinar is to help individuals, teams, and organizations adopt open source technologies, tools, and platforms. And regarding the bonjour and comment ça va, well, I picked that up from Paris. So I'm back from my visit from the city of light, love, and KubeCon. Yes, so all of you must be aware that KubeCon this year in Europe was held in Paris, and I was there. It was one of the best KubeCons I've attended. About 12,000 people in attendance. And apart from the AI buzz, Gen AI, artificial intelligence, one word that took center stage as well was platform engineering. So we did have our first platform engineering day at KubeCon this time around, and it was absolute great to see a lot of people doing amazing things in platform engineering. And in continuation to that, I'm back again with these webinars. We were on a break because I was at KubeCon and a lot of things happened after that. So I'm back with this webinar, and today we would be discussing about platform automation using Crossplane. Now, before I move ahead, if you are joining in for the first time, you can watch our previous webinars by scanning the QR code and heading to our YouTube channel to go ahead and watch the previous webinars, have a look at them. And these webinars are not a prerequisite, which means that you can very well follow today's webinar without watching the previous ones. And when you are on YouTube, make sure to subscribe to our channel. But talking about YouTube, I think one of the things that's very special today is our guest. He needs no introduction. A dear friend of mine, a fellow developer advocate, and someone whom I couldn't get hold at Paris KubeCon because he was amongst a sea of people. So let me bring upon the special guest for today. I have Victor from Upbound. Hey Victor, thanks so much for joining.
Hey, thanks for having me. Great to be here.
Thank you so much. And our second guest is a familiar face, Vishal. Thank you so much for joining in.
Hey, Atul. Good to be here again.
Thank you so much, Vishal. So it's a ritual here. Whoever has been following this webinar, you know that the introductions of the guests is done by themselves. So Victor and Vishal, why don't you go ahead and introduce yourselves to our audience? Tell them who you are, what do you do, and one thing outside of work that you spend time on. So Victor, go ahead.
Oh, it's very hard to answer what do I do. Most of the time, I don't know what I do. I do random things, and some of those things end up being useful. Officially, I'm not officially. I'm a developer advocate at Upbound. Upbound is a company behind Crossplane, and on top of those corporate duties, I spend most of my time with open source one way or another, either contributing or maybe educating or anything else.
Interesting. And Vishal, please
Sure.
introduce yourself as well.
I'm founder and CTO at InfraCloud, doing a bunch of things around Kubernetes, open source, and helping enterprises get it right, I guess. Beyond works, usually love good books, movies, mountains, as you can see from my background. But yeah.
Great. Thank you so much, Vishal and Victor, for that wonderful introduction. So, which means, we have a great diverse platform here. We have diverse people from different places, different interests, and different roles as well. So, today's discussion is going to be really exciting. So, before we get deep into the webinar, some housekeeping rules. We will be taking questions from all of you. So, as and when you have any questions, please feel free to drop them in the comment section, and we would take it up with the speakers and guests here. Or I would also be interacting on the comments as well. With that out of the way, I guess it's time to discuss platform engineering. I'm sure a lot of you would have heard the term platform engineering, either from me talking about all over social media or other experts, who keep talking about it and sharing insightful things that they are doing. Now, every time you listen from me, I'm sure you would have heard a different definition of platform engineering from me, and that's because every time I meet someone new at a different event, I learn more about platform engineering. And today's definition is going to be different from the last ones that I have spoken about. And I've actually taken a note about it. So platform engineering, as someone said, I don't remember who it was, but I remember that what they said. So according to them, platform engineering is actually an enabler that boosts developer experience by codifying IT best practices into reusable and self-service capabilities. Now, it is a very systematic definition, but then I think it covers the entire gamut of platform engineering. Victor, what are your thoughts? How would you explain platform engineering if you had to?
That sounds about right. It's actually, I think that that definition fits well into explaining what a platform is rather than what platform engineering is. And here's the problem, right? If platforms are all about creating services that others will be using, I don't know, that would be service how to define and deploy your application to Kubernetes or a database or a cluster or this or that, right? Uh, if that would be done by platform engineers, that would mean that platform engineers know everything about everything, right? That they're experts in networking, in Kubernetes, in cloud, in everything, right? And that's really impossible. We tried that in the past many, many times. That's like full stack engineers, right? Not a good idea. What we do these days is very, very complex. And it would be unrealistic to expect that people understand not only complexity of certain part of the system, but everything. So we still need experts like database, experts in databases, experts in security, networking, and so on and so forth, as we have today. But what is changing with platforms is that those experts are not anymore reactive. They're not waiting until, I need a database. Let me create a database. They're converting their expertise into services, right? And through that definition, I would say that platform engineering is more about creating a glue, enabling those experts to convert their experience, their knowledge into services. Right? So it's almost like a enabler for other people to expose their experience as services than creating services themselves. Because again, that would mean that you know everything. And if you do, we're hiring.
I think you couldn't have put it better than that. And platform being the glue, I think we all agree to it. Vishal, what are your thoughts on that?
I think Victor put it right. So basically, being enabled, enabling the orgs to be able to do self-service, and not necessarily be the bottleneck in the providing services, so to speak, right? There's only so many people and so much expertise we can have, but if you can write that into code and expose it, it'll just become much more scalable. And I think today's complexity demands that.
Absolutely, absolutely. So that was just a definition of platform engineering from all of us. If you want to learn more about platform engineering, there is the CNCF platforms white paper, which you can go and read. Where we have defined everything about platforms, how you can start, what it is, and everything that you need about that. Now, moving on into the discussion. Now, what we discussed about is just platform engineering, and a lot of people already know about platform engineering. But then there are a lot of individual teams, organizations who, even though they have the right expertise and tool sets, they don't know where to start their platform journey. And keeping that in mind, we at InfraCloud came up with this platform engineering reference architecture ebook, and this is based on our experiences building platforms for our customers, interacting with the community, and attending various talks and just learning what's happening around. And we took our experience and put it in this book. And what you will find in this book is basically a list of capabilities that your platform should have, a number of blueprints to help you and your teams start your platform journey, a lot of reference architecture points, tool suggestions. So this is exactly what anyone would need when you want to start your platform journey. And this book is completely free to download. So all you have to do is just scan the QR code that you are seeing on your screen to get access to this ebook, which has tons of things based on our experience interacting with everyone around platforms. Now, the book has a lot of things, and one of the things that I would touch upon today would be platform capabilities. Now, whenever we talk about platform engineering and platforms, one of the major things that comes to the fore is capabilities. So, when you are building a platform, there has to be a set of capabilities that will be offered by the platform, which would be used by the developers to engage in, building their services, their applications, so on and so forth. So one of the things that we have done in this book is we have divided all the services into three buckets, which is develop, consume, and discover. So all the capabilities that your team requires to build a service itself will fall under the develop category. So things like service templates, workload specifications, environments, progressive delivery, pipelines. So these essentially are capabilities that your platforms must provide to ensure that your developers can actually build the service. Now, at next level, there are certain external components that a service would be using to for its regular functioning, and this is where things like message queues, registry, databases come into picture. So these essentially are consumed, and hence these are put into the consume bucket. And lastly, there are some ancillary systems that are used to do something with the service that you are building. And that's where you have things like observability, fleet management, developer portals, so on and so forth. And all of these services will help you discover more about the application or the service that you are building. So whenever you are building a platform, these are the capabilities where you can bucket all the services that you want your platform to offer. So like I said, this is just one page from the ebook. There's a lot more in the ebook, so which you can go ahead and download for yourself. Now, in theory, we spoke a lot about platform engineering over the past 5 webinars. We also discussed a little about it in today's webinar as well. In theory, it is expected that platform plays a frictionless role. It provides no friction absolutely between the services, the capabilities, and the developers. However, does that happen in real life? Does that translate into real world experience? Let me pose that question to my guest today. So the question here is, what are some key aspects that you feel contribute to a positive or a negative experience when you are working with platform engineering tools and frameworks? Victor, your thoughts on this? You are on mute, I think.
Oh, sorry for that.
Yeah.
The biggest issue I see, without any doubt, right, long before we go into technology and everything else, is not treating platform as a product and not treating everybody else as customers, right? What often happens is that I'm going to call them platform engineers, right? Come up with the idea. Oh, we should do this, right? We should use this tool and that tool, and we should create this form in web and whatever, and people are gonna love it. And then they spend months developing it, and then two things tend to happen. One is somebody in a company, CTO, says now everybody must use this. It's not optional; it's mandatory, right? And that's a horrible idea because that's how people hate you, right? Or, hey, we have this thing. Do you like it? And most of the time, or do you find, more importantly, do you find it useful? And most of the time, the response is no. Of course, I don't find it useful. You did not build it for me. You built it for yourself, right? So it should go through the same cycle as any other real product somebody might be making, right? Figure out what is the market, what does the market need, what are the problems that you want to solve, what is the reaction of your users, and so on and so forth. It's a grind. It takes a lot of time to figure out what people need to begin with.
Absolutely. Absolutely. And I think only when the when you have the right mindset and when you build the right product for the right customers that you have, I think that's when it actually will impact. Positive or negative, would definitely come after that, until unless you don't know whom you are making it for. Vishal, if I have to take this a step further, taking the
Sure.
product approach, building the
Mhm.
platform, and then let us come to the factors, that you feel would impact, considering that we have now built it for our teams.
Sure. So I think one factor which can affect both positively and negative, in my opinion, is the constant battle between the flexibility and rigidity. Now, what do I mean by that? Let's take an example. I want to provision a database, give it to my team, for example, right? I could expose all the 100 parameters that they need to configure, which is absolutely cognitive overload, for them to be filling, for example, right? Or I could say I'm going to limit only two parameters that they can configure. Everything else is, fixed as per my wishes, for example, right? Now, there is no right answer over here. The rigidity is obviously not good. You don't want to expose only two parameters and let everybody else, use the same base parameters. Also, you don't want to expose 100 parameters. Is there something which can offer the right balance for the right, users and right teams? Is I think one of the constant struggles. And on this spectrum, you could achieve either negative experience or a positive experience, both by optimizing, rigidity and flexibility, at the right level, so to speak. And I believe that is one of the biggest challenges because there is no right answer over here. It's a spectrum, and the spectrum could vary team to team, customer to customer, as in team within the company, and technology to technology as well.
I tend to disagree. I think that there is a right answer there. You just need to ask.
Sure, we'll come to
Right?
that.
That's going back to my previous point. There is the right answer. You need to figure out what is the people need and what is the level of control they're comfortable with, right? If it's a database,
Absolutely.
hey, do you want to manage, do you want to choose the database or no? Do you need to choose the database or no? If you do, then we need a parameter for that, right? Do you want to manage the version of the database? Yes or no, right? It's very hard to get to the right answer, but there is a right answer. Just as if you go shopping on Amazon, they do not give me the option to choose whether my package is going to travel by plane or by train or because I don't care, right? But
Right.
there are things that I do
Absolutely.
care, and those things are available to me.
Yeah, no, absolutely, you're right. And I think that's where, as a user, what they want is probably the first point we need to answer.
Just interviews. I think only when you go ahead and involve your users into building the product, only that's when you realize what they really want. I mean, let's say taking the example of database that you brought up. So if the entire team is there and they are using a certain database and they have a certain level of experience, that's when they'll say, hey, I just need two parameters to go ahead with it. Don't give me 10 or don't give me 12. So interesting. I think that was a good discussion on it. While I had some notes around this, but this went in a different tangent, which I am absolutely loving. Now, while we started talking about the product approach, where involve everyone, all the stakeholders to build your platform. Once you have the requirements, that's when your process of actually implementing a platform starts. So that's when you look into the architecture, the tools, and everything that you need to build one. Now, while you are doing that, there are a lot of choices that the teams or the platform teams need to make. From the technology perspective, from the design perspective. So this the next question, is around the frameworks and design patterns. So could you shed some light around the whether there are any predefined architectural patterns or design patterns that the teams must choose to build a platform, or is it something very fluid that again it depends based on what they are building and who they are building it for?
Part of the answer depends on what you already have, right? So I cannot give the same answer to everybody because, hey, you might be working with mainframe for all I know, right? And then whatever patterns I'm going to say do not apply. So my answer is going to assume, okay, let's say that we are starting from scratch, right? We don't have a history behind us. And then there are patterns. And those patterns were established quite a few years ago without many of us realizing. And probably the best example of those patterns is AWS itself, right? AWS would be probably the first example, publicly available example of a platform, even though it's very low level and majority of people cannot use it, but it is. And that pattern is relatively simple and straightforward. And it all boils down to APIs, meaning my job, first primary job, right, is to create a service and to expose that service to the rest of the world through an API. I don't start with the UI. I don't start with CLI. I don't start with Visual Studio Code extension, whatever, right? That comes later or not at all, right? And that's the rule that Amazon established before it even started working on AWS itself. And that's, okay, we have a service that does something. We expose that service through an API. And afterwards, we can think about building a console or building this or that, right? So it's, if there is a, probably the most important pattern would be that API first. And that's not even a part, that's very strange to me that we are not accepting that yet in platform engineering, because that's a widely accepted pattern everywhere else. If you ask any front-end developer, that person, if that person is good, is going to say, okay, what is the API I talk to, right? If there is no API, I'm not doing anything, right? First, we make a contract. This is the API. API matches those needs of the user that we talked about. With previously, you mentioned, hey, should we expose these parameters or that parameters? Exactly, right? That's the discovery phase. Then the next phase is we build an API. We build the API specification. And from there on, we can build services that comply to those APIs. And we can build clients that invoke those APIs. Now, the important, sorry, one more thing.
Yes.
The important thing is that from the user perspective, after that, doesn't matter what's behind that API, right? Whether you run tool A or B or C, irrelevant. Nobody knows what is running behind the AWS API. Maybe they have, I don't know, trolls running around their data center and doing it manually. We don't know. We don't care.
Absolutely. I think, you actually, pointed at the right thing, that a lot of the building or the planning thing starts much before getting into the tools. It starts on pen and paper and brainstorming and boards, and only much later in the stage is when you actually get to APIs and constructs and the UIs and everything. So that's a very, very valid point. Vishal, what would you want to add to this? Either it's on this journey or from the user side of things.
I think Victor nailed with his response. I don't think the framework or the pattern that you use to design your platform largely matters, as long as you're building API first. And over time, it will evolve. Some of the users might end up using a CLI, via API. Some users might end up using a UI via API. But definitely, it has to be API first. And I think AWS is a great example of that, proven over the last 2+ decades of scaling systems and platforms, beyond all of us can imagine, basically.
Absolutely. And I think, you rightly mentioned about evolution. Now, if we go back to the product approach and you look at any of the user applications that we use, it could be Uber or it could be anything for that matter. Now, these are the apps which are always built keeping the user in mind. And one of the things that comes to the forefront when you talk about the product approach is the continuous evolution of the application that you are building. So even in that case, when you have a platform in that, if you're putting platform at the spotlight, it has to evolve constantly. And I think that's where, you rightly mentioned about how the interaction patterns would change over time. It would start with probably an API, and then someone would say, hey, I need a UI for this. And that's when your team will actually build a UI. And then that's how it evolves. But at the base level, the fundamental thing is, again, like Victor said, it all starts on a paper, on a board, and only after that you decide how you want to take that up. Now,
because sorry for interrupting.
Go ahead.
If you do these things right and start technical part with API, everything else, it might not look like that, but everything else becomes so much easier. For example, vast majority of cases that I've seen people building UIs, let's say web UI, right, end up with some hard-coded fields in the UI or using some files to discover something, right? If you build an API, UI, I can build it in a weekend, right? Because UI doesn't have to do anything. It just goes to the API and asks, what can I do?
Right.
That's the only question that matters. What can I do?
Absolutely. Yep. And I think if this on a lighter note, if this webinar was an examination, Victor would be scoring 100 and 100 on every question or every point that we are discussing today. So thank you so much, Victor, for all the insights. Moving on to the next one, so now we spoke about how you start building a platform. We spoke about the design patterns or the framework that one should probably approach with while building one. But then interestingly, there are a lot of challenges that are that are involved in building a platform as well. And these are the challenges that come from a technical perspective, from a skill perspective. So quickly, what are the challenges that you see, when teams are actually starting their journey for building platforms?
I mean, challenges differ really. Probably the biggest challenge is really understanding conceptually the base on top of which you're building it, right? These days, and again, I'm going to use all my examples thinking that somebody starts from scratch because that simplifies the story. The base of everything we do today, and this is not directly related to platforms only, is Kubernetes, right? So whatever you're building, whichever tools you're using, if you're doing it right these days, you're going to build it on top of Kubernetes. You will be extending Kubernetes API. You will be building Kubernetes controllers that serves as your services or backends and so on and so forth, right? And one of the big challenges there, accepting that Kubernetes is the standard today, is experience, is knowledge, right? And that might not look like that because, hey, many of us are experienced and you're using Kubernetes for a long time. But in reality, those experts that I was talking about before, like database expert, or even people involved in infrastructure using, I don't know, Ansible, Terraform, or whichever other tool, they might not be so proficient with Kubernetes, right? Because it takes quite a lot of time to figure it out and to understand. Once you figure it out, it's beautiful. It's easy actually, but it might have a steep learning curve, and for a good reason. It's a steep learning curve because it does a lot of things, right? But that's the major challenge. How can we onboard everybody involved in building whichever technology we're using, but that technology is going to be on top of Kubernetes? How do we make sure that everybody understands Kubernetes in depth? Not everybody in organization. So I'm not asking Node.js developers to understand Kubernetes, but those building the platform, I definitely do expect them to be very proficient with it.
Interesting. Yes, I think learning curve is I think one of the biggest challenges. Whenever we have discussed around, even in the community as well. Learning curve has always come up as one of the top challenges, if I am not mistaken. And whether it is about the technology to build the platform, or it's around integrating it, or it's about learning more about the platform, adoption, so on and so forth. So.
The beautiful thing about Kubernetes, right? Initially, it's very intimidating. Hey, there's a lot there to learn. But actually, on a longer run, it's actually not a steep learning curve. And the reason is relatively simple, because all the tools you might choose that extend Kubernetes or do something in Kubernetes are based on the same patterns, right? So once you figure out Kubernetes itself alone, figuring out 57 different tools that you're going to use is a breeze, is nothing, it's irrelevant, it's extremely fast because they all follow the same patterns. Here, there's a CRD, there are events, there are controllers, blah, 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 blah. Everything follows the same pattern. So on a long run, I would argue that it's actually easier to learn Kubernetes and everything on top of Kubernetes than the ecosystem outside Kubernetes, because they're all very different, right? You knowing Ansible gives you very small jumpstart in knowing Pulumi, and I'm using them as example, right? Or Jenkins, right? Jenkins and Ansible, nothing to do with each other. The experience in one does not give you jumpstart in the other. In Kubernetes is different.
Right. Absolutely, absolutely. And I think I don't know about my audience, but this definitely is one very big key takeaway for me. I mean, I never looked at Kubernetes and challenges in the way Victor has mentioned. The learning curve initially would be very steep, but then once you get a hang of it, things become easier because everything that is built on Kubernetes follows the same pattern. I'm going to be using that a lot. Thank you so much for that. And I think with that we would move on to the crux of today's webinar. We discussed a lot about platforms, a lot about the challenges, the design patterns, and the frameworks. And today we are going to look at one such tool that actually helps us in building a platform and automating a lot of things, and that is Crossplane. And who better than Victor to talk to us about Crossplane from now on. And so, Victor, the stage is all yours. You are on mute.
Sorry. Great.
Yeah.
Can you put my screen there? There. Brilliant. Right. I did not prepare any slides. I like speaking from top of my head, and I like showing things. Right. No slides, no sales pitch, only code type of approach. Anyways, so there are a couple of components or major features in Crossplane one should be aware of. Right. One is something like this. This is one of my definition, and we call that managed resources, meaning that I can install providers. Let's say in this case, I installed some AWS providers, and that extended. Actually, let me show you that kubectl get CRDs. Right, this is my Kubernetes cluster, and let me make this small, just a slightly bit smaller. There we go. And you can see that I extended Kubernetes API with new definitions like, hey, there is something called VPC EPAM pool, right, and users in AWS and so on and so forth, right? So my Kubernetes now understands through the API that I can send requests in form of YAML or anything else you want, and to create instances of all those things, in this case, AWS, right? Now, one example is this, where I want to create a virtual machine in AWS. And you will see that even with this simple example, things are not that simple. And I'll get back to that later, right? So I'm going to create an instance of EC2, and there are some parameters I'm going to use, like this is the image, this is the region, and so on and so forth. Now, instance itself is not enough in AWS. I want to have a state, meaning that it should always be running. Remember that it should always be running. That will become important later. I need a VPC, I need a subnet, and so on and so forth. Now, in a real world situation, I would never do what I'm going to do now. You should be fired if you execute a command that I'm going to execute, and that command is apply file name this, right? I'm saying you should be fired. You should be pushing it to Git. You should be letting Argo CD synchronize it to the cluster, or maybe review it first, pull request, what's or not, or use Flux, right? We have better ways to do than interact with the cluster directly, but quick demo, right? So no Argo CD. Now, what matters is that those resources were created just as you would create pods in your Kubernetes cluster, right? And I can take a look at what's going on by saying, hey, give me all the resources managed by Crossplane. And you can see that, for example, VPC is already created. It's ready. Subnet not yet ready. And instance could not even start being created because probably it requires some information from VPC or subnet or something like that, right? Now, all that, where am I here? There we go. Now, if you go to, no, let me put this on the screen. There we go. If you go to Marketplace, this is all free, what's or not, right? And you want to know what you can do, you can just query EC2 and say, okay, I want EC2 provider. I want to find out what it does. And then here you can see all the resources that you would get in your cluster, and one of them is probably instance, right? Here we go, right? And this is the beautiful thing, right? It's API driven. There is a schema associated with it if my internet works, and you can find out what are all the fields, what is the schema, right? This is the schema of Kubernetes API that Kubernetes API will be extended with, right? Okay, now this is at the same time something that nobody should ever do also. Apart from not interacting directly with the cluster, we almost never create resources with Crossplane like this. I just wanted to show you that you can do it. And you can see that in the meantime, the state for instance was created, right? And if I go to my, let's go to my EC2 instance. Here we go. This is my AWS account. And we should see a VM here. There we go, right? And it was created there and so on and so forth. Now, important thing with those resources managed, and going back to the patterns I mentioned before, right? Many use the Kubernetes patterns. And one of the Kubernetes patterns is that there is a drift detection reconciliation. So it's not only that I created a VM and VPC and subnet and what's not, but there is a process in my cluster that is constantly watching for the state of that something. And if I, for example, if you remember before, I said, hey, that VM should always be running. If I stop it, terminate it here, I'm going to stop the VM, and I'll come back to it later. You will see that Crossplane will say, hey, this is not what you said. You said that you want it to be running, and it will detect that it's stopped, and it will start it again, right? So drift detection, reconciliation, same thing is what is happening with your pods in a way, right? Now, that's a boring part. The interesting part is that I can do two things. First, I can combine those resources together somehow to make something meaningful. Let's say a database, right? I can say, hey, for a database, I need RDS, subnet, VPC, this or that. I need a bunch of things. And I can expose that to my users, to developers, as a new API endpoint. And here's one that I made. kubectl get CRDs, let's say grep DevOps, there we go, right? And you can see that I already created something called, let's find SQL claims, right? I extended Kubernetes cluster and saying, hey, but somebody can create something called SQL claim, whatever that something is. It's a database, Postgres database, right? If I, let me see if I, now, here comes the part. If you would like now to create a web UI for what I'm about to show, you can just say, no hard coded anything. Just go to the cluster, find out what is the schema of that new API endpoint, and you would get something like this. Okay, so, you can specify the size of the database, you can specify the version, you can specify secrets, you can specify schemas, and so on and so forth, right? So everything is discoverable, everything is API driven, and so on and so forth. Now, one way to interact with Kubernetes API is through kubectl, the thing I said that you should never do, right? And here I'm going to create a couple of things. I'm going to go big now. I'm going to say, hey, there is something called cluster claim. You can create a cluster yourself. No need to ask me. And here, this would be a developer writing. This wouldn't be me now. Say, hey, you can use labels to say, where do you want that cluster? In AWS, and you want it to be EKS. What are the size of the nodes? Small, because nobody knows what are the sizes in AWS, right? It's my job as a builder, as a service provider, to actually figure out how to translate that user requirement into whatever AWS wants, right? I will create app claim, I will deploy an application, it will be a backend application connected to the database, and it will be working in that new cluster. That cluster that does not yet exist even, right? And there are a couple of other things that I exposed to developers, like, hey, you can specify an image, right? You can specify in which namespace you want to run it. Whatever we agreed, that should be there. And, oh, I forgot this one. And I'm going to allow you to create a database. And database will be running also in AWS right now, and it will be Postgres, and it will be a small database, right? And inside of database server, there will be a database silly demo DB, right? So you create interfaces. This is all custom. The Crossplane, this does not come out of the box. I need to create those things. One way how you can do that is creating something we called, this is now in the marketplace, because the marketplace is like Docker Hub, but for compositions, what I'm saying, right? And you can see that here I created a composite cluster, and that cluster has schema and what's not. Now, if you're interested in code, I will not have much time to go deep into the code, But you can see, for example, here, there are two important parts to create what I'm showing you right now. First is the definition that says, hey, and this is now Open API schema. This is standard, nothing really special. And this is the schema that I want to create. And that schema has properties field, and inside of the spec field, and inside of that spec, there is ID and parameters. So I'm creating a schema of the API with whichever fields we agreed, and what are the types of the fields, what are values, and what's not, right? And the second part is implementation. So whenever somebody creates something like called cluster claim or whatever they're creating, these are behind the scenes without users knowing what's going on. I will create, if they select AWS CKS, I will create a cluster, and I will create cluster authentication, and I will create a node group for that cluster. And for example, if somebody selects large nodes, if you remember the small that I used before, then this will be translation to what AWS understands, and so on and so forth, right? So I create, I combine all the different resources required. And in this case, when creating a cluster, not everything is AWS. If I scroll down, if I find the button to scroll down, there we go, you will see that I'm creating some, I'm installing some stuff in that, I'm installing some Helm charts into that cluster, I'm creating some namespaces, I'm setting authentication. So a combination of many, many different things, because things are complex, but they don't have to be complex for the end users. Right? Now, okay, so let me go back to my code. That's where I feel comfortable, right? So what I'm going to do is say this YAML, let me show you again, that will create an application and a database. Where is the database? Here, a database connected to that application automatically in a cluster where that application will be running. I'm going to just say, where are you? Here, kubectl namespace is going to be a team, and I want to apply whatever is defined in that file, right? Boom, applied. And now it might take half an hour for AWS to create all that stuff. And some of those things cannot be created right away. Some of those things we need to wait because they have certain dependency in what's or not, right? But what does matter is that if I list all the managed resources, you will see that behind the scenes, those like 50 lines of YAML, user-friendly YAML, I would say, were converted into all this, right? These are all the things that are happening right now in the cluster behind the scenes. Nobody has to know, right? And if I'm interested in something more specific, I can say, hey, we have a CLI. Hey, show me not all the resources, but show me those related to the cluster claim. And then you see, okay, this is what's happening, right? You created a claim, that claim created composition, that composition created internet gateway. It is already available, so those things are happening, and blah, 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 blah. And you can see here, it will create EBS, that's still not ongoing. It will try to create cluster authentication, that's failing. It cannot create it because some other things in a cluster are not yet ready, right? There are all elaborated dependency management without you worrying about dependencies, and so on and so forth. Now, this will take a bit of time. Cluster takes a long time, and in parallel with that cluster, you can see that it's creating a database. This is RDS in AWS. Some of those things are finished, some of those are in progress, and finally, we have application app claim that is being created. No, it's not. What is it? No, wrong name. There we go. Right? An application. Now, application is failing. Everything is failing 100%. Right? And it's failing because I said that I want application, that new cluster that is not yet even, does not exist. Right?
Okay. Yeah.
But when it starts working, that cluster, when it's operational, then application will be running there. It will be connected to the database and all the jazz. Right? Now, I don't expect users, to write this. Some users might be very happy writing this YAML because it's easy. For others, I would create a CLI maybe. For somebody else, I might create a Visual Studio Code extension. For somebody else, maybe a web UI, maybe all of those, maybe none of those, right? Depends on what they want, what they're comfortable with. But that comes later. kind of the important part is that I have that API that defines how we define application. And from there on, everything becomes much easier. That's my quick pitch. I wanted to finish early, so in case there are some questions or anything, I can help. Wait. Let me see.
You are
Last
missing
thing.
something.
Yeah, I'm missing something. I promised at the very beginning of this demo that I will show you that if I destroy my VM, it will be recreated. Let's see whether that's happening. Wrong one. Sorry. Let me see. Now I don't know. I messed up something. I know what. No. I'm not sharing my screen. Now all my VMs disappeared. I'm not sure what I did. I did probably something wrong. But you need to trust me on that one. It did not yet. This is the thing. There we go. It did not yet detected that VM terminated. It will wake up soon and figure it out. That's my quick pitch.
Yes. No, it was great. And I think, Amit says, we love code. I think when you said you love code, Amit also says he loves code. And I think all of us, love code and such demos.
I have the story in my head that, if I go with slides, you don't know whether I'm just repeating somebody else's thing or not, right? Kind of showing the code shows that it's your thing. You know what's happening, right? Even when it doesn't work.
Absolutely, I get that. And demo gods, we know them. They always come when you are live and doing something. So I think
that's okay.
There's a question by Nitin, and I think it actually asks you to check the same thing, which we probably messed up in the demo. So he's asking, does it recreate the VM or simply start the VM? Since you terminated the VM, it should be deleted, right?
It's deleted and now it will recreate it, right? If I stopped it, then it would start it, right? Because it finds the drifts and reconciles them. So now what I'm going to say is not 100% sure always, because it depends on the APIs on the other end. In this case of AWS, like Azure, for example, does not have a mechanism to through the API to start the VM, but if you destroy it, it will. Doesn't have the mechanism to create a VM with the same name and so on. So there are some limitations that depend on the provider. But in general, like in case of AWS, if I stop the VM, it would start it. If I destroy it, it would create it.
Great. So I think it does the entire sync and state, your desired state management. I think Crossplane takes care of that to ensure that everything is in sync.
Yes.
Great. And I think so. So thanks so much, Victor, for that short yet very impactful demo for all of us. And we did see a lot of things that Crossplane is capable of doing, and that's one of the reasons why Crossplane is such a great tool. I mean, even though it started as a sandbox project, today it is a CNCF incubating project, and a lot of organizations and teams across are using it. And
it's going to graduate anytime now. It's about to graduate now. So
wow. So that again is going to be an exciting news for all of us. And I think the demo you gave, it actually very well showcased that when you are building a platform, how Crossplane actually perfectly sits into that landscape, because then it allows you to manage your infrastructure at different places through Kubernetes APIs.
So here's important, and probably the thing I like most about Crossplane, right? Now, usually people, when I say the thing I like most about Crossplane, people expect me to tell you the feature that I like the most, but that's not the thing. What attracted me to Crossplane long before I started using Crossplane and dug into it long before I joined the project, is that it is Kubernetes native. Now, that might sound silly, Kubernetes native, but there is a big advantage to that. And that means that it works seamlessly with any other Kubernetes native tool, right? So we don't have to figure out a way to manage policies, for example, right? Why would you? Why would we add policies to Crossplane if there is Kyverno, if there is Gatekeeper, and so on and so forth? How to synchronize stuff? Well, no, not the problem of Crossplane. Use Argo CD, use Flux. You want to ship logs somewhere? Again, just use the rest of the ecosystem as you would normally do. And that's the beauty. This is not about Crossplane even specifically, right? Beauty about Kubernetes. Everything works with everything else.
Absolutely. That is the beauty of Kubernetes. So yeah, that's about it for the demo. So you can scan the QR code, which will take you to the Crossplane's GitHub repo. Go do go ahead and try it out, and see the magic that it creates, and try to recreate what Victor did, and probably ping him and say, okay, hey, I was able to get that working. So to sum things up, I think it was a great discussion today. We have in fact overshot our regular duration that we have, and that means that discussion was pretty insightful with everyone commenting in as well. So we started by talking about the product approach for platforms, and that is essentially what defines what you do and how you take your platform, right from inception to maturity and then continuous evolution of that. We looked at challenges. The learning curve is steep. When it comes to the different integrations, the different tools that you are adding, and eventually we looked at the tool, of the Crossplane basically, where Victor showed us, the capability that is has, which allows you to deal with managing your infrastructure irrespective of where it is. Uh, I think we are at the top of the time. I'm quickly going through questions if there are any. So we had Yash who says, "Hey Victor, probably I should have taken it earlier," but he says, "Hi Yash, thank you so much for joining in." So yeah, any closing thoughts from you, Victor, before we finally sum up the webinar for today? You are on mute again.
Okay, sorry for that. I just pasted a link in a private chat. If somebody, I created a set of videos as a tutorial, kind of for beginners for Crossplane. If anybody's, it's free. YouTube. No, I'm not selling you anything. If you want to check it out, it's over there.
Absolutely. I have added that chat. I've added that link in the chat as well. So, you can go ahead and look at that playlist as well. So thank you so much, Victor, for giving us your valuable time and with that very short yet impactful demo.
Thank you for having me.
Great then. So once again, thank you everyone for joining in for this webinar. I hope you found it insightful and learned something about Crossplane. I will be back again with another webinar soon. So, keep.
You're muted, Atul.
We lost your audio.
You're muted. Say something.
Yes.
There we go.
Great. So yeah, thank you so much, everyone, for joining in, and I'll see you again with a new webinar in the coming few weeks. So thank you and have a wonderful day.
Cheers, everyone.